All right, everybody. We're going to multiplying rational numbers. First of all, what is a rational number? Yeah, great.
It's either a fraction or a negative number.
A fraction, a negative number. It's a number that can be written as a fraction. Okay? The number -7 can be written as a fraction. What's -7 as a fraction? Brianna. -7/1. Okay? What about these decimals? -2.1. Can't that be written as a fraction? That was part of your assignment Friday. As -2 1/10, right? And then you can make that an improper fraction as well. By definition, a rational number can be written as a fraction a over b. And that can be transmitted into an improper fraction. Alright, so is that important? No. The point is, these are the types of numbers we're dealing with. We're not dealing with just whole numbers and multiplying whole numbers together like you did in second grade and third grade. Okay? So that's why we call it rational. Now we're just multiplying today. How do we multiply fractions together? Parker. Straight across. Top and bottom, just the top, just the bottom? Yeah. So 1 times 3, that's going to be 3. And 2 times 5 is? 10. Is it reduced?
No.
3/10?
Yeah.
3/10 is reduced.
No. It's not. No. It can't.
What? How do you reduce it then?
I said it's not.
It's not reduced or it is reduced?
Well, 3 is like a prime number, isn't it?
I'm asking you, is it reduced?
Oh, yeah.
Yes.
Yes, okay.
Oh.
Yeah.
Can't you like reduce before you multiply?
Yes.
Yes, you can.
But
The question is, can you reduce before you multiply, like the 3 and this 9 diagonally? Only in multiplication are we going to talk about this. You could reduce these before you multiply. Great question. All right, let's do the next one. How do I do that? What do you think you should do to make it easier? Yeah.
Make it over 1.
Make what over 1?
7 over 1.
All right, so we're going to make this a -7/1. You going to do anything with this? What?
make it into an improper fraction.
All right, how do I do that? Hey. Okay, that's right. Who wants to make it? Hey.
Yeah. 4 times 1 plus 3.
4 times 1 plus 3. For those of you, which I know there's some of you in here that forgot how to do that. 4 times 1 is 4, plus 3 is 7. 7/4. Denominator stays the same. All right, now multiply straight across. What is that?
49.
-7 times a +7.
Oh.
-49. So now we are really dealing with not just rational numbers and multiplication and fractions. We need to make sure we understand our signs. And 1 times 4 is 4. Now the question, do I want you to leave that as an improper fraction, or do I want you to make it a mixed number? I would like you to make it a mixed number. I will not count it wrong as long as this is reduced if you leave it as an improper fraction. It's just going to be easier to grade if everybody does the same thing. Got it? Okay, so this is reduced. If you left it like that, that would be okay. But go ahead and make this a mixed number for our notes.
It should be -12 1/4.
Awesome. 4 goes into 49 12 times with a remainder of 1, and the denominator stays the same. It's negative. Don't forget your negative. You'll get it counted wrong. Okay, Neffy?
So it's better if we all just do that.
Yeah, just to make it easier for grading purposes. The other part, guys, is -12 1/4 is easier to understand that value than if you're looking at -49/4. It takes you a second to process how big -49/4 is, right? So just to make it easier for processing in your own brain when you're reading problems, it's better to have a mixed number. And that's the way you should do it, just because it's better to understand, easier to understand. All right, example 3. What do we have? Who wants to do this one? Example 3. Brianna. on each side, the 3 and the 9. Okay, so she's going to reduce, excuse me, she's going to reduce diagonally before she starts. Just like this is 3 over 9. She would divide this by 3 and divide this by 3. All right, that becomes a -1. This becomes +3. What about 5 over 5? What?
It'll be 1.
What? You divide them both by 5, right? Well, that's a 1 and that's 1. All right, now what do we have for an answer?
What about the negative?
Okay, the negative stays there. This becomes -1 up top. So since I carried them, I'll just erase them there. Brianna. All right, what's -1 times a -1? +1. And 1 times 3 here is 3. Now that's really messy. I'm going to go ahead and do it again down here without reducing diagonally. So for those of you who struggle with it diagonally, let's do it this way. Straight across. -3 times -5 is a +15. And a 5 times 9 is 45. Now I can reduce both of those by 5 or more. Let's do by 5 first. Those of you who weren't sure. 15 divided by 5 is 3. 45 divided by 5? 9. I expect everybody to answer if you know the answers. Is that reduced?
No.
What can I reduce it by?
3.
3. So divide both by 3. And I get 1. Sure. Same thing. Good? All right. Excellent. What are we going to do this? What are we going to do here? Make it what? Improper fraction. Okay. 6 times 7? Everybody. Plus 3?
45.
So that's 45 sevenths times 7 eighths. Now, do I really want to take 45 times 7?
No.
Someday you're going to have to. You got a calculator. But why don't we just reduce diagonally? 7 over 7, that reduces to 1 over 1, right? Now what do you get?
45 over 8.
Yep. 45 over 8. That is reduced, but go ahead and make it a mixed number. Somebody make it a mixed number for me. Chandler.
It'd be 5 and 5/8.
Yep. 8 goes into 45 5 times with a remainder of 5. And the denominator always stays the same. Good. So all that is manipulating, changing the way things look. All right. -2.1 times -7. Go ahead and use your calculators, but in general, what do you know about this, Brianna?
Change -2.1 to 2
You could, and then do your multiply fractions. Just go ahead and use your calculator. Okay. We're past this sort of thing of changing things back to the fractions and multiplying through. I want you to go ahead and just use your calculators on this stuff.
You could take it, you can get rid of the decimal by putting a decimal at the end of the 7 and moving it over 1. I think, no.
You could. Take 21 times 7, is that what you said?
Yeah.
70. You could do that. He was saying get rid of the decimal by multiplying both of these by 10. That would make this -21, that would make that -70. And then multiply it out. So there's been 2 ways that we could do this so far. Brianna said we can make this into a mixed number and then an improper fraction and multiply them out just like what we did up here. Quentin said we can multiply this by both of these by 10 and change that decimal. Okay. Move the decimals over, but why not? -14.7. There's, but it's not negative. Why not?
Oh. Negative and negative cross
Right, negative times a negative is positive. So this is going to be 14.7. Is that correct?
Yes.
How many decimals are shown? How many decimal places are shown in the problem? 1. How many decimals are in your answer? 1. Okay. How many decimal places are shown here? 1, 2, 3. So there better be 3 decimal places in your answer. All right, on your calculator, take that Figure it out for me. I'm not going to make you put these into fractions here, okay? What do you get? Nothing.
Negative 0.42.
Negative 0 point what?
42.
Is that correct?
Yes.
No, there's not 3 down.
Put
Oh,
0.
no. But, yeah.
You don't have to put that 0. How many zeros are after the 2, by the way?
Empty.
Infinitely many. You didn't need to put that. But thank you for thinking about that. All right, I'm going to go back to this for a second because nobody said anything. If I multiply by 10 here, what are you going to get for your answer?
Wait, what?
He was multiplying by 10 to get rid of his decimal. If you multiply negative 2.1 times 10, it becomes negative 21. Why doesn't that work in this expression? Because you take negative 21 times negative 7, you're going to get 147, not 14.7. Now all of a sudden your answer is wrong. Why is it wrong? I'm going to be impressed if you understand this.
Because it's a whole number, not a decimal.
Right, but here's the rule that you guys are going to learn here in the next chapter. Quentin.
Because I forgot to say that you gotta put your decimal back in.
Yeah, you got to put the decimal back in. But you don't have to do that if this was an equation. One of the rules with manipulating equations is if you multiply or divide by something on the left side of the equal sign, do that to the right side as well. And that keeps it balanced. And you wouldn't need to move the decimal after that if you changed both sides. But we only have an expression here, not an equation. We'll get to that when we get to equations, okay? Because it's going to be a rule that you're going to have to memorize. We'll write them up all over. All right, we good? Awesome. Your assignment.